We're the portable grill group. My name is Lucas DeSantos. To my right, you have Nico Fabian and then Gina Lee Smith. Our sponsor for this project was Greg Hummel, and our advisor was Dr. David Brown. A quick overview of the project. We were basically tasked with creating a portable electric grill that runs on a battery-powered source, with the purpose of the project being the ability to cook grill and food products while in remote settings, like while camping or on a boat. The impact of this would be to replace the use of a propane grill. That way you don't have as many of the risks involved with the gas.
So the first requirement is that it must be rechargeable. This is pretty much one of the most important requirements because it's kind of pointless to have an electric grill if you can't recharge it. So the battery pack that we use must be able to recharge off the wall, and it must recharge in a total time of at least 5 hours. And we are limited to the charger that comes with the battery pack. So the second requirement goes hand in hand with the first, that it runs on electricity. So it must run for approximately half an hour before being able to recharge. And it must run on DeWalt battery-powered sources of at least 120 volts, because that is the standard that you get from wall outlets. The third requirement is the temperature, and it must reach a surface temperature of at least 350 degrees Fahrenheit. Anything lower than that, and food can be unsafe to eat at that temperature. So to lower the risk of that, we want to be at least 350 degrees or higher. The fourth requirement is portability, hence being able to take this thing practically anywhere. So it must be easily handled by at least one person, weighs less than 40 pounds, and dimensions not exceeding 11 inches wide, 20 inches long, and 36 inches high. And the last requirement is safety. One of the goals of this project is to make it safer than a propane grill of the same type.
So just an overview of the project. Basically, it's a power source connected to the grill. You charge it and reuse it, allowing for the indefinite use of the system. Some of the alternatives we looked at, initially we thought of the idea of making our own custom 120 volt battery pack with 18650 cells. Some of the challenges with that would be incorporating circuit protections for overcharging, over discharging, overheating, and current drop. We could have also used a car battery coupled with an inverter to output 120 volts to heat up the elements, get it hot enough. And then upon meeting with our advisor for the first, sponsor for the first time, we actually discovered he wanted us to use power tool batteries. So we went back, tested all the methods to see if it was feasible. And then regardless of which type we decided to go with, it was important that we found the lowest wattage grill possible. Online we found that the lowest one was a 1200 watt grill, George Foreman from Home Depot. And then if that wasn't enough, if we needed a less of a wattage, then we'd have to make our own custom design. And that's ultimately what we ended up doing. We ended up going with the DeWalt power station, which can output up to 1800 watts and runs on 420 volt DeWalt batteries. And we used two 300 watt heating elements along with a stainless steel surface and a stainless steel body. These are some of the technical designs we initially went through. So in the beginning, we actually got the initial description of the project, and we thought about using the car battery and the battery pack. So we decided using the 1200 watt would be the way to go with a custom 120 volt battery pack. But then after meeting with the sponsor, we went to design number 2, which was the custom grill with the 2060 flexible DeWalt batteries. And this was in the first semester. Second semester, we actually discovered that there's already a solution for this out in the market, so it kind of defeated the purpose, and we wanted something original. So we went back to using making our own 120 volt battery pack. But lastly, we didn't have enough time in the semester to actually complete the project, given that we'd have to make those circuit protections, and we wouldn't make it in time for the presentation, so we actually went back to the DeWalt power station source.
So basically, these are like the technical specifications that we use for the grill. So at first we thought we would actually weld the heating elements onto the stainless steel surface, but we realized that our stainless steel surface was too thin, so instead we decided we would use brackets instead. And as you can see, those are the schematics for the brackets right there. So basically, this is just like the actual photo of what the grill looks like. So as you can see in the left photo, you can see the heating elements attached to the heating surface with the brackets. We also have a thermocouple in the middle to regulate like the temperature to prevent the heating elements from taking too much current from the battery and end up making the battery die faster than we needed it to. On the right hand side, you can just see like what the actual grill looks like next to the battery pack. So the test methods we use, so for the first one, we used our sensors, so we would heat up the element, we put like our hands above the element to make sure that it was actually heating properly. And then for the analysis, we just used like a computer simulation to show like the actual heating before we built everything, so we would know that it would actually heat up and work. And then for the demonstration, we just used like a thermal gun we didn't use a thermal gun first. First, we heated up the actual heating elements attached to the surface of the stainless steel, and then we used a thermocouple gun to actually read what those temperatures were to act, so we could see that those temperatures were actually like modeled off of what the computer simulation showed us. And then for the test, we actually ended up just cooking a piece of steak on the grill, and we have a video showing that later on in the presentation.
So for the test plans, we ended up mapping each one of those test methods to each of our requirements depending on the need of the requirement. So for example, for it to run on electricity, it's pretty easy to inspect that it can run on electricity because all you have to do is just plug it into the power station and you can tell that it runs on electricity. So for our results of the different tests, for rechargeability, the power station that we ended up buying ends up charging the batteries along with powering them too. So what you can do is once the batteries have discharged, you plug it into the wall and then it'll charge all 4 batteries simultaneously. So it reduces the initial time that we thought of 5 hours to charge the batteries to 1 to 1.5 hours depending on how much the batteries have discharged. So for running on electricity, once again, we use the DeWalt power station for it to run. And we do use the DeWalt batteries and they do go in conjunction with the power station. You need both the power station and the batteries for this thing to run. And for temperature, right above the heating elements, we ended up getting it to the temperature to about 450 degrees Fahrenheit. And as you move further away from the heating elements, the temperature starts to drop off. This is because of air getting into the system and it causing energy loss. And because of that, another function or another different way for the energy to be lost is how the heating elements are placed underneath it. With the brackets, they aren't so fastly secured as if, for example, welding it, because if we welded them to the plate, then less energy would have gotten out of the system and more of that could be used to heat the plate. For portability, it's easy to move both the power station and the grill separately, but together it's a little more work. They weigh 33 pounds combined together, meeting our weight requirement, but it does not meet the dimensions requirement because we are adding a whole new system into the design in form of the DeWalt power station. And for safety, it is safer than a propane grill because we are not using gas, so there's no chance for gas leaks or gas explosions. And any wires that we did use in conjunction with the heating elements and to actually plug into the power station, they're all secured underneath the grill body, I should say. Just in case if any liquids get on top of it, they will not be able to short any of the electricity components going inside of it.
As you can see here, this was the computer simulation that we ran. We ended up using console to do it. So as you can see, a lot of the heat, as Nico was saying, was actually lost to convective heat. So you can see that you can see where the heating elements actually are. So on the left-hand side, you can see how much heat was actually generated to the surface. It was roughly around 350 degrees Fahrenheit to 400 degrees Fahrenheit. If you translate those temperatures from Kelvin into actual Fahrenheit, and then you can see on the right-hand side, it's showing the bottom part of where the heating elements were mounted. And you can see that the heating elements get into the 700 Kelvin range, and then not too much heat was translated back to the surface of the steel, but enough was translated to the surface of the steel that we could actually cook food on it. So then this is the plan and schedule. So this was basically for the first semester. We ended up not spending as much time as we thought we would on the actual project. this just shows like the spring semester, and we actually ended up spending a lot more time than we thought we would, like particularly for like the cooking, for the testing, we ended up spending 15 hours instead of like 10, and for measuring the grill surface, we ended up spending double the time that we thought we would.
So in summary, we were actually able to make a prototype of a working portable grill. The grill can definitely be improved with better use of the connection with the heating elements, as well as a larger battery pack. If we got larger capacity batteries, then the system would run for much longer. It can still, ultimately, it does cook the strips of meat. Some lessons learned. Communication was definitely something we needed to work on more because we didn't meet with our sponsor until much later in the first semester. And if we had met with him sooner, we would be able to know exactly what he needed for us to do in the beginning instead of making that assumption of the 120 volt battery pack. Also, we could have researched a little bit more into the DeWalt system. If we had, we probably would have found the power station, and then we would have realized that the system had already existed, and we would have been able to go back to the 120 volt custom pack earlier, and we would have had more time in the first and second semester to work and create a system that would meet his needs more. And then here we have the demonstration. There is a lot of background noise, but you can actually hear the meat sizzling and cooking.
It smells so good.
And that's it. Any questions?